Today we're going to be talking about set notation, and set notation is just a way to write our domains and ranges for our functions. So here's two ways that we can write our set notation. We can use the braces with these symbols, or we can also use our brackets. Both of those can go around your set notations. Now this statement here means that the set of all x's such that, so this first part is our x, this line here is going to be either a line or two dots, is such that x is bigger than 0 or more than 0. So we're going to read it just like we read our inequalities. So x is more than 0. Same thing for this one. We have our x's such that x is greater than 0. Now we can also have these new symbols. We're going to have this one. It kind of looks like a weird E, and that symbol means that it's contained within. So when we have this, we have x is contained within. This r is going to mean all real numbers. So all numbers that are positive, negative, or 0. So x is contained within all real numbers such that x is greater than or equal to 3. So when we write this out, it says the set of all x's contained within the real numbers such that, so that's our colon, x is greater than or equal to 3. So let's look at our first example. In example 1, it says, what is the domain and range of the following graph? So again, we're writing the domains and range in set notation. So first thing I want to do is think about what are my ordered pairs for this function that I can see. So my first point I can see here is at negative 3, 0, negative 3. I also have a point here at 1, 0. Here at 2, 1. Here at 3, 0. And here at 4, negative 3. So remember, our domains are our x values. When we are looking at our x values, it's the first part. We have 0, 1, 2, 3, and 4. So our x's are our domains. So again, we said our domains, and this function is going infinitely in this direction. It's also going infinitely over here. So our x's are going to continue to go out and out and out and out and out and out and out. So when we go on our x-axis, as it comes further out, they're getting positive. They're also getting even more negative on this side of our function. So right now we said our domains, there's going to be some in the front. We don't see all our ordered pairs. There's something there. But our first one that we can see is 0, then 1, 2, 3, and 4. And again, it's still going to be continuing on our x-axis. This function is still going out and out. So there's still more here. So we have this set of domains of 0, 1, 2, 3, and 4. Now, if we want to write this in set notation, we have to use this format here. So I'm going to use a bracket. So I have x such that, and when I'm looking at my x values here, they're going infinitely negative. They're also going infinitely positive. So it's all of our x's are going to be contained within any of those real numbers. So all real numbers. Because they can be negative, they can be positive, and they're going both ways. Now we're also going to be talking about our range. Our range are going to be our y values. So we have this -3, 0, 1, 0, and -3. So some of our ranges are repeating. So remember, if they're repeating, we don't have to write them all out when we do this, but we do start with -3, then we go to 0, 1, 0, and -3. So all of our ranges would be -3, 0, and 1. Now, when we write this in set notation, we are saying that we're talking about our y's, our ranges. So y such that y, and now these y values, when we're looking at it, they're starting, this is where our first y value, our highest y value will be right here, right? Y's for this function, it's going infinitely in this direction. It's going to keep going this way down. So when we look at our y value, it has to be smaller because all these y's, our highest one is 1, is going to be 0, -1, -2, -3, -4, and 5, and it's going down and down and down forever and ever and ever. So y such that y is less than, and this line is solid, so it's going to be equal to 1. So any number that is smaller than 1 could be true. And now the reason this is, and let's pull up my graph here in Desmos. This is the same function graphed on a coordinate plane. When we are looking at our ranges, they're going to continue to go down from 1 for forever. I can zoom out the whole way and they just keep on going the whole way down. Now the same thing's happening with our x's. We said it was all real numbers. Now, even though it looks like it's kind of getting bigger here, if we kept scrolling and scrolling and scrolling, eventually it would keep going out to these larger numbers, which is why we're saying it is all real numbers, because it's never ending. So let's go back and talk about how we would write this. Okay, so we just said that our domain is x such that x contained within all real numbers, which means that the set of all x's such that x is contained within all real numbers, so any positive or negative number or 0. So our range was all of our y values such that y is less than or equal to 1, so anything smaller than 1. So this means the set of all y values such that y is less than or equal to 1. All right, let's look at example 2. So what is the domain and range of this graph? So looking at this graph, the first thing I notice is I have an open circle and I have a closed circle. And we know with inequalities, if I have one of these two symbols, that is going to give us an open circle. And if I have these symbols, that gives us a closed circle. So we're going to have two different inequality signs when we're representing these domains and ranges. All right, so looking at my domains are my x values again. So when I'm looking at this graph, I'm really trying to represent what is happening between these x values. So that's my lowest and my highest x value. So when I'm talking about my x's, it can't be anything over here or over here because it has to be in the middle where this graph is actually being represented. So when I create this in set notation, I'm going to be saying that I have my x, so I'm talking about domains, such that my lowest x value is this point right here, which would be -5, -2. So -5 is going to be my smallest amount. So x, and x is going to be somewhere in the middle of this. So my smallest amount for my x value is -5. Now, I have the symbol, I'm saying this is smallest, so the smaller side should touch it, and I have an open circle here. So my x value can't be equal to -5. Such that, so x such that -5 is less than x, because that's our lowest, and we're also looking at our highest point up here. And our highest point up here is at 4, 3. So our highest x value is going to be 4, and this is a closed circle, so I'm going to be able to be equal to 4. For my range, I'm looking at my y values. So my y value, the highest that I'm going in this y would be up here. And my lowest for my y value would be right here. So I'm trying to figure out all the y's between this point. So for range, y such that my lowest number was -2. It was a closed circle, so it's going to just be less than y. And my highest y value would be that +3. And I am allowed to be equal to it, so we'll have that equal to line. So when we have this for our domains, that was our y value, our domains, it said x such that -5 is less than x or equal to 4. So this means that the set of all x values such that x is greater than -5 but less than or equal to 4. So x has to be greater than -5 but it also has to be smaller than or equal to or less than or equal to 4. Okay, so let's look at a few more. So we're going to write set notation for the following graphs. So looking at our graphs, I'm going to first look at my x values. Okay, so our top ordered pair here would be at -4, 7. And our bottom ordered pair that we can see is going to be 6, -2. So when I'm doing my domains, my x values, I'm looking at how far it went this way and how far it went this way. Remember, when we're talking about our solution, none of the answers for this function can be on this side of our function or this side. They have to be somewhere in the middle. So when we're writing our domains, we are saying x such that our lowest x value is -4, and our highest one is 6, and our x in the middle, right? So we know that because these are open circles, we're not going to have the equal to signs. So 4 is the smallest, so our smaller side of our inequality sign will touch it. So -4 is less than x, and is less than 6. So again, we could say this is x such that x is greater than -4, but less than -6. Now, when we look at our range, that's our y values. So we're looking at how high that range went up here and how low it went. So it's falling somewhere in the middle of this. So we're trying to say what numbers are in the middle. So when we look at our range, we're talking about our y values, and we're trying to figure out what is our highest y value, which is 7, and our lowest y value, which is -2. And again, we still have open circles, so none of these inequality signs will be equal to. So we know y such that it is greater than -2, but less than 7, because it's somewhere in the middle. Okay, we're going to do one more together, and then I'll let you try 2 on your own. So looking at this next one, our domains, again are looking at our x values, and they're going to keep going on and on and on and on forever in these directions. So if that's happening, if it's going to infinity in both directions, we're talking about all real numbers. So when we look at this, x such that x is contained within all real numbers. Because it can be any number that's negative, and it can be any number that's positive, and it could be 0. Now, our range, we're looking at how much is moving on our y-axis. So our lowest range is going to be the bottom of this function right here. And it's going to be anything above that. So when we talk about our range, our y value such that y, and our lowest point right here, this point is 0, 1, so our lowest y value would be 1. And y can be anything that is above that. And it can be equal to it because it's a solid line. So we can say this as y such that y is greater than or equal to 1. Anything above that would be true for this function. Okay, so what I would like for you to do is try number 3 and 4, and then you can come back and check your answers. If you have any questions, please make sure you raise your hand and talk to your teacher. Go ahead and pause the video. So looking at number 3 and number 4, we're looking at our domains. So x such that x, our lowest x value, was 0. It was down here. And our highest was 11. So our lowest x was 0, our highest was 11. So we could say that x such that x is greater than or equal to 0 and less than or equal to 11. If we're looking at our y's, our ranges, we can see that our smallest ordered pair is down here, our point is down here at -2 on our y-axis, and our highest two are up here at 2. So y such that -2 is less than or equal to y, or we could say this as y such that y is greater than or equal to -2, but less than or equal to 2. So those are our highest and our lowest values. For number 4, we're looking at our domains again. We can see that these are going on forever in that direction. So it has x such that x is contained within all real numbers, since it's going infinitely in that direction. Our range would be our lowest point for our y value. Our lowest number would be -1, and anything going in this direction and the upward direction would be true. So y such that y is greater than or equal to -1. Anything that's bigger would make this true. If you have any questions, please make sure to pause and ask your teacher. If not, thank you for watching our video.